Yeah, this session is getting recorded. So once the session is completed, I will share the session also.
Awesome, thank you.
Okay.
Okay. Muhammad is not available in the demo class, let me brief about something about what is MQ, and the same thing will continue today's class also. So as we told, actually MQ is a message-oriented middleware, so which is used for the to interact the two business applications. Okay, to interact with the two different business applications. So as you know that MQ will be the interfaces which will be used for the to talk to the one business application to the another business application. So we have the so many advantages why we are going for only MQ. So when we have the multiple vendors, the same features are providing, but still we are going for the MQ as a middleware, as a MOM tool to make a communication between the two different business applications. Why? Because so MQ having the so many good features other than the same kind of features we are providing by the other vendors. So those features are, first one is, so it will be deployed in any operating system. So MQ will be deployed on any operating system. It means operating system independent. Okay. So if you take a like MSMQ or ActiveMQ or SunMQ or JBoss MQ, there is some dependent. There is dependent with the few operating systems. If you take a ActiveMQ or SunMQ, so these are the operating system independent tools which are providing same kind of feature as a MQ or as a IBM WebSphere MQ, but there is some dependent with the operating system. But MQ, there is no dependent with the operating system. It almost support for the 80+ operating systems. So we are providing the support. So we mean to say you can deploy, you can install the WebSphere MQ software into the 80+ operating systems. That is the main advantage. The second one is, so as you know, MQ we are providing the assurance your request. If you are sending a request from one place to another place, the message will not be lost anytime. So we are providing the assurance your request, 100% assurance, assured delivery. Assured delivery. We are giving the 100% of assurance. If you are sending from request from the one place to another place, if I have example, some Java application want to talk to the some different C application for the business requirement. When the both applications are running in the different system, so I am using intermediate as a MQ as interface between the two different system. When I am passing the request from one system to another system, that request should reach to the destination. It should not be lost any time because of some network failure, some hardware failure, whatever it may be, any failure reason. So you should provide the assurance to your request that message should be reached to the destination. So MQ is providing the assurance of your request. So we are providing the 100% assurance. So this is the reason MQ is popular once again. So this is the feature of MQ.
One question, Ram. I have a question real fast. For what type of messages are these? Are these like commands that are being sent through converting to different applications, or is it messaging as in email?
Yeah, that can be anything actually. Either it is command, either it is text format, either it is XML format, either it is ASCII format. Depends, which is understandable with the backend application. If A is some Java application, C is something like COBOL application. Java will understand that some XML format, but COBOL will not understand the XML format. So what? So the front-end application will convert into the COBOL-related format, either any which is understandable to the backend application. It will send to the backend application. But MQ will not do any kind of transformation. MQ is a simple transport layer. Blindly, it will send the request from the one source to the another destination. It doesn't any convert the data in between. Okay, the request may be any kind of request. If it is a command format, if it is a text format, if it is ASCII format, or COBOL related XML, anything, CSV file or anything. So it doesn't matter. MQ will not bother about the what kind of data we are transferring. It simply transport the data from one source to the another source. Understand, Mahmoud? Is it clear, your doubt?
Yeah, I understand. Thank you. Yes.
Okay. So for converting a data, we have another tool that is called actually message broker. So MQ will not do any conversion. Message broker will does the conversion. So what kind of format you want to be sent to the destination? The next one is we are providing the messaging, asynchronous messaging. MQ will provide synchronous messaging. So it means if both application, if A is an application, B is an application, if both need not to be sync, both need not to be available at the same time, even though the request will be transferred between the two different systems. Whenever the application is available, respective application is available, so that time your request will be processed and send reply back to the caller. So this is called actually asynchronous messaging, means both application need not to be available in the same time. The second one is synchronous messaging. MQ will support asynchronous also. It means both applications should be available during the put and get a time, during the sync point. During the sync point, so if some application putting message, immediately other application should process the request, so that the processing is nothing but a unit of work. During the unit of work, both applications should be available. So MQ will be support for the even sync messaging also, asynchronous and synchronous messaging. Okay, and MQ will not depend on any protocol. For example, here A is some application which is called some Java, B is some application which is .NET application. Okay, for example, A Java application internally they are using some TCP type, transport type they are using for sending request to the one place to another place. The network transport they are using TCP IP. B application they are using some UDP, transport type. Okay. Even though MQ is intermediate, right, interface is right, it will not bother about application what kind of transport type using. So MQ internally they will make one transport type, but MQ level transport type should be the same, but application level what they are using we are not bothering about. So okay, so application level what kind of transport type we are using will not depend on the application level transport type. But MQ level there is one transport type, it will be same for the both A application, B application. It means transport free application. It will not depending on what kind of transport type using by the human experience training audio quality. Okay. So is it everybody find that what I am speaking? So are you able to hear properly?
Yes. Yeah, I'm able to hear. No, it's clear.
Okay, fine. Just let me know if you are not able to hear immediately. Okay, or else you just message me here. Yeah. So that transport type.
So when we say transport
type free application.
Yeah. So Ram, when we say transport type, we're talking about you know, the what do you call it, protocol that's being used to transport the message, right?
Yeah.
Okay. Thanks.
So that is internal application, Java or SAP application or .NET application or any application they will use internally to talk to the MQ. It will depends, their application depends, they will use a transport type. So it is not depending on MQ level. It will not be bothered about application what kind of transport protocol they are using. Okay. The next one is MQ we are providing as a common interface. If for example I have the 10 applications which are running in the same system, okay, So 10 applications which are connecting to the 10 different applications again, different backend application. For example, like A is a front-end application, B is a back-end application. Like A application, I have 10 applications I have. Like B application, I have 5 applications I have. Now all front-end applications, they want to communicate to the back-end application. I have to prepare one adapter which can understand to the back-end application. So both A and B should be communicate each other. If I don't have any MQ system, here, I should use adapter to make understand between the two different application. So if I have the 10 application, 10 different adapters I have to prepare to understand both by the backend application. Here, for example, COBOL, C, RPG, these are the different applications which are available in the front-end application. Okay. For example, backend, there are some other some backend applications, some database or other application. So if the COBOL doesn't understand Java application, right? So I have to prepare COBOL to Java understandable adapter. Here you feel that there is no MQ system. I have these all applications. So those applications want to communicate each other internally. They want to communicate each other. So you don't think the MQ is available? If MQ is not available, in our environment, I have to prepare one adapter which can understand to all the applications. So C doesn't understand .NET application. So C++ to .NET I have to prepare one adapter. Or Java doesn't understand C++ language, because of Java is a object-oriented programming, like even C++ also object-oriented program, but both are different programming language. So I have to prepare one adapter who can understand both applications. So like that, each and every application, if you want to talk to any other application, I have to prepare an adapter. Okay, this will actually taking the huge time for developing adapter. So this will be development overhead and management. So they will think actually they have to prepare so many adapters, right? So they will have to spend so much money to prepare the adapters. So to avoid this kind of issues, we are going to introduce as a interface for the MQ all the applications. So here MQ is a common programming interface. You need not to prepare any adapters. MQ itself is a one adapter. So this adapter is the common programming adapter. So common programming interface. So MQ is a common programming interface. You need not to prepare any interfaces to communicate each other. MQ itself, it is a one common programming interface. So we are reducing the development task. You need not to prepare any adapter, so that you can spend some money, some time to develop your environment. Instead of preparing adapter is providing by the MQ itself, right? So we are reducing the development time also. Okay, so due to this reason, so MQ is very popular. You need not to prepare any adapter, so that MQ itself, it is a providing adapter. If I have 100 applications, you mean say 100 adapters I have to prepare. So MQ, it is reducing so much time. You need not to prepare an adapter, right? So that you can spend some time to work on your different application, a different enhancement, a different feature. Okay, so that we are reducing the development task. So these are the main advantages. So when we are going for the MQ, so MQ itself, it is a common programming interface. Okay, and next one is MQ will not depending on any processing time. If A application is running in the India, B application is running in the US, both are different time frame, actually different time zones. When a caller is sending from A to B, B will process your request as per the US time zone and send reply back to the A caller. It will receive the format of only Indian time zone only. It will not depending on any time frame or time. It is a time independent processing. It will not depending on time zones. The next one is MQ is a application parallelism. MQ will support application parallelism. For example, here I have an application called something called, if you see that Go IB IBO, which is a website to where you can you can travel to the from using, you can book the flight, you can book the hotel, or you can book the transport facility, right? Which is a web application where you can book the all kind of features. For example, I'm using as a Go IBIBO for traveling to US. So what I will do now, I will go to the goibibo.com and I will book the information accordingly where I want to travel. So I wanted to travel to the US for some time, so I wanted to book the flight. And after that one, once I reach to the US, I wanted to stay there for some time, so I have to book the hotel. And after that, I have to transport. I need a transport to the from the area in the US. So I have to book the transport facility also. So in one website, so we are entering all this information. We are entering all this information where I want to go, when I want to go, all this information we are booking, right? Once the request is enter into all this information, so car related information will go to the transport related system. Who is handling by the transport related system, it will go to the request to the transport. Flight information, it will go to the flight who is handling by the flight system. Hotel information which will go to the hotel related system. So means all these three systems are different system, different backend system. The Go IBIBO, it is a front end system, it is single application, but single application it is sending request to the multiple backends at a time. So that once all the places your request will get success and send reply back to the caller saying that your request has been confirmed. Hotel has been booked and flight has been, what are the tickets has been booked, and cars, transport information also has been booked. So all these three information will be available in the single response. So reply to queue. If you see the request we are sending to the three different queues. These are the queues where the request is lying. Car rental, it is going to the car transport related database, whatever the system. If it is flight, the flight information will go to the flight system. So hotel info, it will go to the hotel system. These are all the three queues. The request is moving over the queue only. Then the reply we are coming to, the reply is coming through the single response. We are booking the single front end. The response also we are coming into the single response only. So it means, so MQ application will be using for the application parallelism. The same request we are booking in the one request only, but it will be dividing into multiple backend requests, and it is crossing by the all the backends similar time, and we are getting the single response. So MQ, which is possible to make the application parallel processing. So this is called actually parallel processing. The same one request will be dividing into the multiple backend requests, and we are getting into the single response. So application will be a request, what are the details we are giving, those details will be processing by all the backends at a time, and we are getting the single response. It will not wait for the any backend failed or any backend is not available. It will not wait, because we are sending the sync response. We are sending the sync response. I will not wait for the more than 1 minute. So if the one backend is failed, you will get the failure response at least. You will get the failure response. I will not wait for the to complete the request, whatever the backend is available. So we will get the failure response at the same time immediately. So this is called actually application parallelism. So MQ will be using as a application parallelism also. And the next one is faster application development. So as we told, so if you are using as a MQ as an interface, it will giving the adapter facility. You need not to prepare an adapter, so that application directly use that adapter to talk to the one application or another application. So it's reducing the development task, development time. So fast, you can improve your application in the different framework, different level. So like that, so we are using the faster application development purpose also. MQ also one of the good feature. Okay, apart from that, so we are providing that high availability and scalability and latency and output through. So these are the features we are providing to the vendor when he is choosing as a MQ, an interface between the two different systems. So anybody, any doubts so far?
No, it's good.
Okay, fine. So let's see that what is a message and what is a queue. So as we are telling that message queuing, right? So what is mean by message? A message is a string of bytes. It contains some meaningful information. So which is used to talk to the one business application to the another business application. So message will talk to the one system to another system. So instead of calling application to application, we are sending a message. That message will talk to the one system to the another system. That is called actually a message. So what is a queue? A queue is a safe place where we can store the message. A queue is a safe place where we can store the request, which is a kind of one database structure. What is a one table kind of structure actually. So but it is a database we will call as a table. But when coming to the MQ level, it is a one file system. So it is a one file system where the data will be stored. So the mainly we are using for the queue is to storing the request in sequential manner. So once the request is placed in the queue, the message will be processing by the consumer in the two different types. One is the first in first out and is the priority. What is the delivery sequence? The delivery sequence will be the first in first out, or delivery should be priority. If you set the priority, if I am sending the 10 requests, out of 10 requests, the 7th request is the highest priority, 9. I am giving the highest priority is 9. So 7th message will be processed fast, and rest of the message will be processed accordingly. Okay. If you set the priority, so based on the priority also your request will be processed. Okay. So this is how the message will be processed in the queue. So here the 4 types of messages we have. The first one is request, reply, report, announcement, or we will call as a datagram. So what is mean by request message? A request message is a message which we can expect the reply. So when you are talking about the request, for example, I am giving you some balance inquiry over the mobile. So I wanted to know some balance of my mobile. So when you enter the USSD code, some kind of *123#, it is the USSD code to get the balance inquiry. So when you enter the *123#, it will go to the system, the telecom operating system. So it will verify all the backends. Whether it is prepaid or postpaid. If it is prepaid, what kind of information he has. If it is a postpaid, what kind of information he has. All the package information will be displayed over the mobile. So this is called actually request. We are doing some request. We are giving the request to the application, so that application will backend application will process your request and send reply back to your mobile number. Okay. So that is called actually request. What is a reply message? I am doing *123#, right? When you are doing the *123#, you are getting response. So a message of requested message, which is a message of requested message. A reply message is nothing but which is a message of requested message. So means we are getting the balance in the format of which is understandable by the caller, right? So that is called actually reply. What is mean by report? What is mean by report? A report or event, we will call as a event. Whenever there are some specific conditions satisfied in the application level or queue level or MQ level, whatever it may be, we will report, we will generate some events. My request, I am sending from A to B application, right? I am expecting the COA and COD, confirmation arrival and confirmation delivery. My application internally, he has written the code saying that whenever the request reach to the queue, I want to get the COA, confirmation and arrival. Once the request is processing by this application or the service provider. So once the request has been processed by the service provider, I should get the confirmation and delivery. So those kind of events if you want to generate, so application has to write the code internally, he has to get the COA, COD. These COA, COD will be generated by the MQ queue manager based on the request by the front-end application. The front-end application is requested that whenever the request is reached to the queue, I want to generate COA, confirmation arrival. Once the request is received by the consumer, whatever the service provider, I should get the confirmation delivery. Those events will be generated by the MQ if the application has been requested. Okay. The next one is announcement. What is mean by announcement? It is nothing but a datagram which we cannot expect any reply. We are giving just announcement, update statement. We are announcing that. So when you do the update statement, you will not get any reply. If you see that when you are doing some updating the statement into your database, it will just update. It is not a select query. Okay, we are updating the data in the which is existing information. So like that. So this is called actually announcement. So which cannot expect any reply. So these are the 4 types of messages are available in the MQ. So which will support by the MQ system. The 4 types of messages. Okay, you understand this one? Any doubt here?
No, I'm good.
Okay. Okay. So when you are putting a message to the queue, so the application will define the message descriptor. Message descriptor. So what is mean by message descriptor? So it will describe over the what kind of message we are sending to the queue. We are sending to the queue. I have some Java application. So Java application is putting some message to the one queue, right? So that message, what kind of message we are sending? How to identify that one? So what kind of message we are sending? So what kind of, once the message has been processed by the destination, so we get the reply, right? To reply to get whom I need to get the reply. Those information have to put into the message header. Message header. So that message header will call as a message descriptor. It will describe about message. Even it will be a descriptor about your message. Okay. Each message, when the message is being sent by the application, it has 2 parts. It has 2 parts. One is message descriptor and application data. Message descriptor contains the descriptor about your message. It means what is the message type, whether we are sending the datagram message or announcement or request or reply, what kind of message we are sending, what kind of message format we are sending, whether it is a MQ string format, whether it is a ASCII format, whether it is a text format, what kind of message we are sending. Okay, who is the application sending, what is the message ID, what is the correlation ID, so all, what is the reply queue name, what is the reply queue manager name, all the information will be available in the message descriptor. Message descriptor. I will show you that one, then we are going to the practically. So what is the message descriptor? So when, and after that, the next one is application data. So this is the message. The message will be dividing into 2 parts, as I told you. One is the message descriptor, second one is the application data. So application data is nothing but which we are sending, what are the XML, what is the command. If you are firing any command against to the any application, this command, the command information. So all this information will be available in the application data, which is the actual data. We will call as a actual data. So when you are sending, when application is sending a message to the queue, the message will be dividing into 2 parts. One is the message descriptor and application data. Based on the message descriptor only, your message will be processed accordingly. If the message header having any issue, your message will be fail accordingly. If I am sending a message descriptor, message which is understandable to the backend application, unfortunately I have changed that header. I have changed that header which is not understandable to the backend application. It will fail. Application will not able to read the data because the message header which is not understandable by the backend application. So we make sure that when you are sending a data from the one place to one system to another system, that system, backend system, should understand the message, the header of your message. Then only your message will be processed accordingly. If I am sending the MQ string format, but opposite it will understand only JMS format. So I have to prepare one application internally which is understandable by the even JMS also. So that you need to prepare like that application should capable to read the JMS header also or MQ string format header also. Otherwise, your application will be failed. Your message will be failed. Yeah. Once the message has been reached to the queue also having some header. As I told you, before sending a message, the message has been two parts. One is the message descriptor and is application data. Once the message has been sent to the queue also having some header. So this is the queue level header. So again, the before coming to the queue, the message having two parts. Once the message coming to the queue, it has the again three parts: destination queue name details, destination queue manager details, and original message descriptor. All together. So we'll call as a three parts in the message. One is the message descriptor and transmission queue header and application data. So these are the three parts. So when the message is coming to the queue. So this is about the queue. This is about the message descriptor. Message descriptor. What is the message? What is a queue? And how the message is getting divided? And how many parts of messages? So what is contained in the message descriptor? All. So we have discussed so far. So when we talk about that application and MQ, so how application is talking to the MQ? Any idea how application is talking to the MQ? So application will talk to the MQ using the API calls, which is we'll call as a MQI calls. I have a Java application, for example. This is Java application where it is hosted in the some system. This is some Java. App. I have installed MQ in the same system here. I have installed MQ here. Now Java want to talk to the MQ. First, when you install both the system in the same place in the same system, Java doesn't understand, doesn't know whether the MQ is available in the system or not. You should be aware of, so MQ also available in the same system. How we will aware? So the two methods Java will talk to the MQ. One is the binding mode. So by making the binding mode, the client mode. So using two different methods, Java will talk to the MQ client, MQ server. Java will talk to the MQ server. Now binding mode means, so here MQ related libraries, whatever the MQ related libraries, I will set the class path. I will set the environment variable to the Java application level, so that Java will talk to the MQ. Client mode means Java application level, I will set the environment variable for the by creating the MQ level channels. So I need to create some MQ level channels. So using those channels, so I will talk to the Java to MQ. So when the application Java and MQ is running in the same system, 99% they will go to the MQ binding mode only. They will go to the binding mode only. They will set the environment variable at the Java application level, so that now Java will talk to the MQ application. Now, how Java will talk to the using the binding mode? How it will connect to the MQ objects? How it will connect to the MQ objects? Using the MQI calls. Using the MQI calls. Using MQI calls. So, what are the different types of MQI calls we have? The first one is MQ con. Second one is MQ open. Third one is MQ put. Fourth one MQ put one. Like that we have so many MQI calls we have. So using this MQI calls, so application will talk to the queue manager. What are the MQ object? Either put or either to get the message from the queue. So these are the MQI calls will be right into the Java application to talk to the MQ objects like queues, like channel. So those objects will be discussed next class. So before that, I'm just briefing about how Java will talk to the MQ application. So using these MQI calls, so these are the MQI calls has to be right into the application level to connect to the queue, either put or either get the message from the queue. I will show you in application how application will be writing this code. So there are some sample application will be providing by the MQ itself. So using those, by seeing them, we will understand that how application will talk to the MQ. So by writing the MQ calls. Tools. Now this one. Okay, it is not get installed properly all the applications, I think so. Actually, that MQ version it is not getting installed properly in my system. So this is the reason it is not able to show you all this sample application. It should be available here under sample, under tools. Under tools, all applications will be available. So SOAP is an application, right? Like C, Java, JMS. So like that, all applications will be available. Okay, those here it will be like the application how it is talking to the MQ. Those information will be available. Okay, I will show you in the next class how application will talk to the MQ, how the application will be writing in the code. For example, I have one sample application, it will be there. This is actually client mode. So this is a sample application I have written here. So this is the client mode where that he has to specify the channel name, host name, and port name, everything. So MQ, we are talking to the application will talking to the MQ by using the client mode. As a MQ administrator, you need not to bother about how application is talking to the MQ. I'm just showing you for your reference only. As an administrator, you should not bother about how application is talking. So if they will ask you to create a channel, you should create. They will ask you to provide the environment variable related libraries. You should provide to those libraries to them, so that they can set the environment variable and they can post the request, or they can connect to queue manager like that. So these are the methods they will use for to talk to the MQ. Okay, this is the application how it is connecting using the channels. So this is the client mode. This is the client mode. Here, if you see that they are asking the channel name. They're asking the channel name, they're asking the host name, port, user ID, all this information, right? So it means they are using the client mode. Okay. I will show you the next class in the sample applications how it will talk to the MQ under. So because they will write the application related code, API calls. These are the MQI calls. So we'll call API calls and MQI calls, both are same. So these are the different types of MQI calls will be used for to talk to the application will talk to the MQ. One is the MQ put for sending a message, MQ put one also sending a message. The difference between MQ put and MQ put one is within the unit of work you can able to send the multiple messages, which means I can send the more than one transaction using the MQ put call. But when I am using MQ put one call, I can send only one transaction at a time, and this transaction will automatically get closed and disconnected from the queue manager and queue. You need not to invoke again MQ close and disconnect call. MQ close and disconnect call. Automatically application will be disconnected once the transaction is completed. But when I am using the MQ put call, application has to write the MQ close and disconnect call to disconnect from the queue manager. This is the difference between the MQ put and put one. The next one is MQ get call. So application it will go and fetch the data from the queue, right? So they have to write the MQ get. The next one is, these are the connecting and closing from the queue manager. So there are some objects like queue manager, channel, like, right? So those objects, if you want to connect it to the queue manager, first he wanted to connect, and after he want to open the queue and he want to close the queue, and in between he will write the MQ put and MQ get call. So like these are the MQI calls.
Ram, quick question for you. For MQ put and MQ put 1, for MQ put, if we don't, if we don't close it, is there any issues?
Yeah, definitely, because see, when you open that MQ, when you issue the MQ put call, if you're not closing, so it will be burden to the application. Again, that it will wait for this. What happened here? Queue manager will take it will burden to the queue manager. So because immediately another application will try to put message to the queue, it will not be able to put message because it is already opened by the different application.
Okay.
Otherwise, here one more thing. Already one thread only he will put message to the queue, right? The same thread will go and listen to the reply queue. But when the request has been already sent, it is not disconnected properly, you will not get the reply.
I see. Okay.
The same thread, whatever the Java application using thread concept, right? One thread is open to put message to the queue. The same thread will go and listen to the second reply queue also. If the thread still it is connected to the only request queue and it is not disconnected, so then it will be a problem. Actually, it will not committed that message. The message should not be committed. So when the close and disconnect call issued, then only it will be committed the transaction. Until unless the request is not committed, whatever the application is not disconnected, the transaction, it should not be committed properly. It will be burdened to the MQ also.
Okay.
Okay.
Yeah.
Yeah. And the next one is inquiry. If you want to inquire how many messages we have, what is the message properties, we want to set the MQ any properties, so then we will issue the MQ inquire and MQ set properties. So I put message and I want to commit the transaction. So you should use the commit transaction, MQ commit, MQ commit, MQ icon. If you want to start the transaction, you should use a MQ begin transaction. So like that, application has to issue the these many MQ icon when he wanted to put and when he wanted to get the message.
And
here actually, Nazir, what happened here? If you did not issue the MQ close and disconnect call, your transaction will not be successfully committed.
I see.
Okay, and MQ has to manually commit the transaction. That will again, so MQ level, MQ administrator has to go and check and he has to commit the transaction.
Okay.
Okay.
And these are from.
Is there any? Sorry, go ahead, Nazir.
No, I was saying, just for clarity, all of these commands are at the application layer. The application sending these back and forth, right?
Yes, yes. This is an application level. Application, how application is talking to the MQ, either to put or get the message, they has to write these MQI calls.
I see.
As an MQ administrator, you need not to bother about how application is connecting, how application is putting a message. We just showing you. I'm just explaining you because how application is talking to the MQ. This is just for your information only.
Okay. So
because when he is connected to the queue manager, he will get some error. He will get some error code. He will tell that while connecting to my queue manager, I'm getting some 2035 error code, MQ reason code. So based on that, we need to troubleshoot that one. He will tell that I'm trying to open a queue, I'm getting some error code, 2053, put is inhibited. Like that, he will say he will face some MQ reason code. So based on that, we will troubleshoot. As an MQ administrator, we will ask them when you are trying to access MQ, what kind of error code you are getting. So they will provide the error code and they will provide the what is the exception they are getting, so that we will troubleshoot accordingly. So whether it is putting, when he is putting message, while he is putting message, he is getting error. While he is connecting queue manager, he is getting error. While he is opening a queue, he is getting error. We will ask them so that they will provide the details.
Okay.
Okay. And these are the different types of MQ icons. And today we will see that one more topic. So we'll see what is the different types of MQ objects we have. Okay. So in MQ level, when you install the MQ software, so we have to create some objects. We have to create some objects. So before that, let's see that what are the different types of MQ softwares are available. MQ, MQ. One is MQ server. The second one is MQ client. So MQ server is the server where we can create the runtime objects. Runtime objects. Those are queue manager, queue, channel, listener. Like that, we have so many objects. Okay. So MQ client is a component. It will talk to the queue manager. MQ client is a component. Just it will use it to talk to queue manager. Okay. So it doesn't have any runtime components like queue manager, channel, listener. So those MQ objects will not be available in the MQ client software. So MQ server, when you install MQ server, by default MQ client also will get installed if you want. By default, when you buy the MQ server software, you can get the MQ client also. It is a inbuilt software, MQ client software. If you want to use that MQ client software, you can install MQ client software also. But it doesn't require to install MQ client software. But MQ, when you install MQ server, so we can create all these objects, queue manager, queues, channel, listener, etc. So MQ server we have to buy with the license. We have to buy with the licensing. Okay. But MQ client component is a free software. You can download from the IBM server with a free of cost. There is no licensing for the MQ client software. Okay, which is a component, which is some jar file kind of thing actually. So these MQ client component will be used for the to connect it to the queue manager, either put or to get a message from the queue manager queues. So we have the two types of softwares are available in the MQ. One is the MQ server. The second one is the MQ client. The latest version of MQ is latest 8.0, 8.0 and 7.5 also. Because 7.5 they have released in 2012, the beta version. 2013 it got popular actually. So since 2013 they started using the 7.5 version, and even recently they have launched 8.0 MQ version. The people they started even using 8.0 version also. There are the ongoing the versions are 7.5 and 8.0. The old version are 7.1 and 7.0 version. These are also still the market using. Okay, these are the different types of MQ versions are available in the market. So we will be working on now 7.5 and 8.0. Both the versions we'll look into that one. Okay. So our
Hey Ram,
hello?
is this versions are dependent for the WebSphere versions? Hey Ram,
yes, Raj?
Is these versions are depends on these versions are depends on WebSphere versions? Like if I have WebSphere 8.5, is this any compatibility, or if you want to install?
No, there is no compatibility. Even WebSphere Application Server, it will talk to even MQ 5.3 version also. There is no compatibility.
Okay, that's fine. Thank you.
Okay. Yeah, that message broker having some compatibility with that one. Okay, MQ 6.0 will not work on MQ. If it is NB, I have the 6.1 version is there, so I can install till 7.0 only. If I have the 7.5 version MQ, it will not talk to the MB 6 version, 6.1 version. So there is some compatibility with MB.
Okay.
So Nazir, are you there?
Yeah, Ram, I'm here, but the thing is I have a meeting exactly at 11 Eastern, so I have to put on the mobile. I can see your screen, but I'm headed to the meeting right now. But I can still see what you're discussing.
Okay,
Will the meeting be over?
Yeah, that's fine.
11?
I will, if you want, I will disconnect the today's session. We'll continue tomorrow if you have any meeting or something.
Okay, yeah, but the thing is, my meeting is it's every day at 11 p.m. Eastern.
Oh, is it? Okay, okay.
Yeah, so I don't know how long the session is.
Can we prepone to our class? It means like my time 6:30. Is it fine for you?
6:30. No, you know what? I thought it should be from 9 p.m. Eastern. No, 10 p.m. Eastern to 11 p.m. Eastern for 1 hour. Is that good or no?
Okay, okay.
And as he's talking about 9 p.m. Eastern to 10 p.m. Eastern, is that works? He's talking about the 6:30 in IST.
I'm just talking about 6:30 IST.
No, actually, if 6:30 IST, the problem is I'm actually taking another class at 8:30 Eastern till 9:30. I mean, yeah, 9:30 Eastern.
Okay.
Oh, is it? Okay, okay. Is it fine the same timing? How we are taking the class? The same time will be. Is it fine for you?
Yeah, the time is perfect for me. The only thing is, it's I would have to leave literally 11 p.m. I would be out Eastern.
Okay.
Yeah. So if you discuss anything after that, I'll be in another meeting. Sorry. So if you know the times that we're supposed to be scheduled for